All right, so now that we've talked about conditional types, let's take a look at something called indexed access types. All right, now in order to demonstrate what indexed access types are and how they work, let's create a new file inside our source directory. We'll say indexed access types.ts. And inside here, what we're going to do is we're going to start off by defining a simple interface. So let's say something like interface, and for now, we'll just use something like car, all right? So our car interface here is going to have a few properties. It might have something like make, which would be a string. There we go. It might have something like model, which would be a string. Maybe it has a number of miles, which would be a number, and so on and so forth, right? All right, so if we wanted to create an object with this interface as its type, right, we'll say something like let car equals, and then we'll create a new car object. So we'll say make, we'll say Chevrolet, and then we'll say model, and we'll say something like Camaro, and then we'll say number of miles, and maybe that's something like 10,000. Okay, well in this case now, if we wanted to get the value of one of these properties, all right, so let's say something like let car name, and we'll make that a string here, and set that equal to car.model. Well, in this specific case, we know that this is going to work because we know that car.model is a string, and we know that car name is a string as well. However, if we were to now go in here, rephrase. However, if we were to now go into our car interface and change something about the model type, right? So maybe we make it something like string or number if there are cars that just have a number as their model name. Well, we can see that that's no longer going to work, and we would have to come down here and update the type of our car name variable to string or number. And presumably if we had done things like passed this car name to a function of some sort, we'd have to change the function, and that small type change would basically spread throughout our code base potentially. So what indexed access types allow us to do is look up the type of a property inside another type that we've created, right? So in other words, for our car name here, if we're just setting it equal to the value of car.model, instead of saying string or number and just basically repeating what we set up here in the interface, we can just tell TypeScript that we want this car name variable to be the same as whatever the type of the model property is on our car interface. Now, what that looks like here is we can just say car with a capital C because we're talking about the car interface here. And then in square brackets, just like we would normally access the value for a key in a JavaScript object, we can just say car and then the type of the property that we want to look up. So in our case, that would be model, right? So what this will do is it'll tell TypeScript that we want this car name variable to be the same type as whatever the model property is on our car interface. So if you hover over car name now, you can see that that translates to string or number. And if we go back here and change this to something else, right? If we say just string again and change it back, then you can see that car name will now be a string. Okay, and if you had specific functions that were only meant to work with car names, you could set this as the type as well. Now in our case here, we just hard-coded car model, but we can actually also use this to create a custom type if we want to. So if we wanted to say type car model equals, then we can just say capital C car and in square brackets model. And we can now use this as a custom type, right? So if we wanted to say car name, car model, then we can see that that'll have the same effect. And that might make our code a little bit more readable and might make it a little bit easier to tell what the intentions were with a certain piece of code. So the good news here too is that with indexed access types, we can combine different property types together. So let's say that we have a variable and we want it to either be the type of the car's make or the type of the car's model, right? Well, right now they're both strings, so let's just set the type of model to string or number, right? We'll make that assumption that we made a little bit earlier. Well, now what we could do is we could say let car name equals, and if we want the car name to be equal to either the model or if there is no model name, which could be represented by having a question mark there, then we want it to be the car's make. Well, in that case, what we could do is we could say let car name equals car.model or car.make. Now, in order to get the correct type declaration for this line here and tell what we should declare car name as, we need to actually look up here in the interface and see that make has the type of string and model has the type of string or number, and it's optional. And then we have to do a little bit of mental arithmetic and figure out that, this car name variable could either be a string or a number. And we come back to the same problem that we were running into before, right? Where if we change one of these types, then we would also have to change the type down here, and so on and so forth, right? So what we can actually do using indexed access types is we can say something like let car name equals, and then we can say capital C car model or capital C car make. All right, so, here, this should actually be type instead of let. And then what TypeScript will do is automatically combine these types together, and we can now use that for the type of car name by saying car name like so. And as you can see, this type works for this situation. So anyway, that's really the idea of indexed access types, again, is that they allow us to look up the type of a property in a custom type that we've defined instead of having to just manually go through, copy the type of that property and add it to our variable. All right, so anyway, that's indexed access types. The next thing that we're going to take a look at here are template literal types.